Well, hello everybody, and thank you, Stefan, for the introduction and the opportunity to present here on the new working group on OPC UA for AI. And it was a deliberate choice to name this as I named it right now. So this is really how can OPCUA present information so that AI models can actually make use of them? So AI, especially in this latest incarnation of the large language models, which have been commercially available for a bit more than a year now, has of course taken the industry by storm, and it has touched a lot of aspects of this. And of course, in this space, there's a lot of hype that is currently going around, and there's also some fear on what these AI models will mean for workers, for technologists, for the skills that we all have in programming, working with computers. But I have the belief here that this is something that will actually enhance the abilities of people working in industry and basically become something like a superpower. So let me start with a view of what you've probably all seen. AI, especially in the form of large language models, but also in other techniques, is something that is useful for engineering. So it can be used as a tool to basically build solutions, for example, in manufacturing process control, but in general software engineering at all. And this is also what we've seen. There are tools today which are surprisingly good in writing simple software. This is clearly not something that's going to replace expert programmers anytime soon, but it replaces a lot of manual search for starting points and for basic understanding on how, let's say, an interface is going to be used, on how a certain function can be implemented, or even some very simple things such as creating an initial starting point for documenting existing code. So it can basically be a useful tool. It has so far been mostly used for programmers in standard languages, right? This is where your C program gets generated, or your Python code gets generated, or JavaScript gets generated. But there is really an opportunity here where we can also use generative large language models to generate code for specific domain-specific languages. So this is not yet just your standard code, but this could be actually something that is only used in a specific domain. And the way how this is done is that we can either build specialized large language models for a specific programming language, but in many cases, since the structure of these programming languages is always very similar, a lot of those existing large language models, with a little bit of fine tuning and clever prompting, can actually create this for many other programming languages as well. Um, and that also gives us another opportunity. We can actually use code that has been written in these domain-specific languages, and we can actually use this code as an input and then ask these models to convert into other languages. Now, this is clearly not something that will work in all cases, but again, it will be something that enables programmers to just get a starting point, to basically get an initial translation of the code and then do a manual refinement so that the code exactly does what is expected. But I think there's more potential here, especially in the domain that OPCOA addresses, right? We have the ability to also take into account specifications and data in this domain. And I think this is where it's going to become really powerful, because now we can actually take a device documentation and create a specification from it that is then machine readable and then can be used in programming tasks, for example. And that can be as simple as really starting from PDF documents, just a documentation of a device, for example, where in the documentation is explained what data the device can provide, and that can then create something like a specification that can be then used further. An example, my colleague Erich Banchett showed this with the reading of documentation and creating a Web of Things specification from it. We can also then use this to convert from existing specification standards and convert them. And again, with some clever prompting, we don't need new large language models for this. The existing large language models can basically be used by just providing them with the right information. And then once we have this machine readable specification, we can also use that for code generation. So now we basically can take the specification that's been generated, we can take some instructions, and we can take some information about the program languages to be used. And then for that purpose, large language models can again create initial code that can be used to talk to those devices. So this really helps the engineers that are writing software for devices, for the cloud, by basically eliminating a number of these very tedious tasks of basically collecting information, of finding sample code, adapting the sample code for use case. It will not go to 100%, so I don't really see this as something that will essentially replace people. It will give them a superpower. But even beyond engineering, software engineering use cases, there are other ways how large language model can really empower. And one aspect is really data analysis. So in data analysis today, we often have at least two people being involved. There's one person which is the domain expert and basically knows exactly what this thing is about. And then there will be somebody who actually knows how to program that programming language that you need. But natural language interaction with data actually allows you to just formulate natural language queries. So that basically means not for every type of query, you need to have a data scientist who writes queries in a specific query language. Instead, the domain expert itself basically gets empowered. They can just ask questions. And we have technical examples on how this can be done. One important and very powerful pattern that we see with these large language models is something called retrieval augmented generation. So basically, you ask the question is then used to generate a query. The query is then run against the data you want, and it's thrown back and into another invocation of the large language model. Now the question is answered based on the data that has just been retrieved. And so you basically get a natural language answer. And those queries can really be something very different depending on the data sources you have. One thing that the AI people really love is the ability to search through documents via a specific embeddings model. So an embeddings model is something that an AI model kind of that represents what is the semantic information contained in text. And by this, without doing a plain string query, which may or may not match, you can ask about concepts and an embeddings model can find the relevant information. But it can also be just creating queries as simple as classic SQL queries against databases. And that is really going to enable the experts. But again, now we're thinking about engineers. But let's think about the end users. There's also potential that these AI models can actually be used on the factory floor by the people operating the machinery. Let's say, you have a person that tries to basically do a fault analysis to get the line up and working again. And now the same approaches can actually be used in front of the machine by basically going through documentation, looking for these embeddings-based indexed information, what is relevant here. And that doesn't have to be just the documentation, could also be existing fault records, existing manuals, existing logs of people on how problems were fixed in the past. But at the same time, you can actually use the data that comes off the machine. You can still use that as part of the retrieval. And then the interesting part is that these large language models is really, they are able to really combine all this query into something that gives you a natural language answer. But again, there's another aspect of these AI models today. We have large language models that can really immediately work with audio input. So imagine these questions do not have to be typed. They can actually ask in natural language. And then that basically opens a lot of possibilities, because those large language models are also very good in following instructions, or maybe taking FAQ documents or procedures for error analysis into account, because they're all formulated in language. And now you basically get to something where you end up asking the machine why something is happening or why something is not happening. And based on the information we already have for humans to follow, these language models can follow it and basically accelerate fault analysis. And that brings us then to another intriguing idea. It's the collaboration between parts of an automation system and the humans around it, enabling natural languages. So basically, imagine you have a machinery where instead of using a touch screen and going through a menu structure you may or may not be familiar with to find a certain thing, imagine you can just instruct the machine by natural language. And that could then basically create situations where an interactive user in front of a machine can actually enable flexible manufacturing by basically just telling the machine what to do. So I agree that there are certain aspects of this that really look like there is a lot to be done to really get to this point, and also to create it in an industrial environment that has its own requirements for reliability and for the user interfaces with the different groups that are interacting with manufacturing systems. But the idea here is that we can basically start by providing specifications such as OPCUA in a form that these AI models can actually use. And that is why we created this working group. So the idea is really that we have these aspects that we want to enhance AI models by providing them information based on what OPCUA already has, which are the companion specs and the core specification. So we have the information that already is a textual description on how a lot of those automation devices actually work. So the idea here is to basically, let's look at these use cases. Yeah, can we use AI in the engineering phase? Can we create information based on our information models that can actually be used by those AI models? Can we use configuration files and create these configuration files, create code for OPCUA interfacing, and then in the end, think about, this data retrieval, and also this idea of having a capability that ends up in the devices basically providing a new type of user interface. That basically complements what we have today, which is panels or programming devices and so on. And we will see where we'll get by this. But the main idea is really to create a pool of data that allows AI companies and automation companies to use this data to inform large language models and other AI systems on what is OPCUA and how to interact with OPCUA-based devices, and how to basically enable these use cases when the information is actually available via OPCUA. The working group is now about to form. We have an initial list of members that consists of some employees of the board companies. We'll soon extend that beyond this. The next phase will be to really define the charter of this working group and define also a roadmap on when to achieve what. And that is the end of my presentation. Thank you very much.